Good evening, friends. Today we are going to start CAE Oxford Aviation Academy series for ATPL ground training series, Airframes and Systems. Today we are going to discuss 10 questions. Question number 1: what is the purpose of main wing spar? We are seeing what is the purpose of main wing spar. The main wing spar, here we can see the main wing spar of the wing. First, to withstand bending and torsional loads. B, to withstand compressive and torsional loads. C, to withstand compressive and shear loads. D, to withstand bending and shear loads. We know that the main spar starts from the edge of the end of the wing to nearly more than half of the value, and it helps the wing to withstand bending and torsional loads. So A is the correct answer. What is the purpose of wing ribs? First we will see where the wing ribs are there. Here we can see the wing ribs are there. Over it provides the shape and the support to the skin of the wing. So our options are A, to withstand the fatigue stress, B, to shape the wing and support the skin, C, to house the fuel and landing gears, D, to provide local support for the skin. So it is providing support to the skin, and in addition to that it is also providing the shape to the wing. So our answer is B. Question 3: what are the purpose of stringers? Here we can see these are the stringers of a wing. We can see stringer, 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 stringer. So what is the purpose of stringers? 1, to absorb the torsional and compressive stresses. B, to produce stress risers and support the fatigue meters. C, to prevent buckling and bending by supporting and stiffening the skin to support the primary control surfaces. So our answer is C, to prevent buckling and bending by supporting the stiffening of skin. Question number 4: the airframe structure must remain substantially intact after experiencing A, the design ultimate load times a 1.5 safety factor, B, the design limit load plus the design ultimate load, C, 3 times the safety factor, D, the design limit load times a 1.5 safety factor of safety. So we can see that what is the definition of a design limit load. This is the maximum load that the designer would expect the airframe or component to experience in service. The standard design limit loads are for transport aircraft, it is plus 2.5 G when it is coming towards the ground landing, and minus 1.0 G for utility aircraft 4.4, and for aerobatic it is 6. These values are based on G forces and derived from the failure values determined experimentally at the design stage. So basically we are going for a transport aircraft. So limit is plus 2.5 g minus 1 g is 1.5 g. So the design limit load times a 1.5 factor of safety. Now the question 5 is, in the construction of airframes, the primary purpose of frames or formers is to A. Provide a means of attaching the stringers and skin panels. B. Oppose hoop stress and provide shape and form to the fuselage. C. Form the entrance doorpost. D. Support the wings. We can see the frames or former. Here we can see the frames or former. What it is doing? In a monocoque structure, all the loads are taken by the skin with just light internal frames or formers to give the required shape. Even slight damage to the skin can seriously weaken the structure. Extra strength needed to build in around holes in the structure for windows, doors, or under carriages, as these will weaken the structure. This type of construction is only suitable for smaller aircraft. Formers. On it, we can see the skin is being attached and it is providing shape also. So, what is hoop stress? Hoop stress. Here we can see after pressurization, the pressurization provides a stress on the body, and this is outside going body. It is called hoop stress. So, 5. The primary purpose of frames or former is to provide a means of attaching the stringers and skin panels, oppose hoop stress and provide shape and form to the fuselage, form the entrance door post, support the wings. So B is the perfect answer for this.